Alright, welcome back. We'll do another exam question on quadratic simultaneous equations. So this time let's do one which may seem a bit more confusing, but the maths is essentially the same. So let's say x plus 2y is equal to 3 and x squared plus 3xy is equal to 10. So let's call this A and let's call this B. So as with last time, what I want to do is take the linear equation, in this case this one, and rearrange it to make x or y the subject. As most of you would probably do, x is probably easier to make the subject here. So 3 minus 2y. So what I'm going to do is label this one C, okay, for future reference. Now I'm going to now substitute into the nonlinear equation. So wherever I see x, I'm going to substitute in 3 minus 2y. So conveniently enough, x squared becomes 3 minus 2y all squared plus 3, and this time xy, so 3 times, I'm going to use a bracket, x times y, and it equals to 10. So now let me change pen and I can expand this further. So 3 minus 2y all squared means this, plus, and what you might want to do is just, so you can think of this as 3 times y and then multiply it by 3 minus 2y. Because you're multiplying all three of them together, so 1, 2, 3, it doesn't matter what order you do it in, it will eventually be simplified the same way anyway. So 3 times 3 is 9, 3 times minus 2y is minus 6y, minus 2y times 3 is minus 6y, and minus 2y times minus 2y is positive 4y squared. Be careful with that. Now 3y times 3 is positive 9y, and 3y times minus 2y is minus 6y squared is equal to 10 rather. Okay, now why is this important? Is because I can now start to see the quadratic structure of ax squared plus bx plus c is equal to 0. So if I was to just simplify it, let me do 4y squared minus 6y squared, which is minus 2y squared. Let me now do minus 6y plus 9y. So minus 6 is minus 12. Minus 12 plus 9 is minus 3y. And I've got this positive 9 left over is equal to 10. And because I want to keep it equal to 0, I'm just going to move all of this over to the right hand side, okay, by doing the inverse. Now, why am I moving the left hand side over to the right hand side? Reason why is because I would rather keep my y squared value positive, okay. Now I could just move the 10 over to the left hand side, and that would, but just that this one is a bit more convenient, a bit simpler for me to do. Answer will still be exactly the same. Okay, so if I was to do that, minus 2y squared becomes positive 2y squared, minus 3y becomes positive 3y, and 9 is a negative now on the other side because it's inversed. So 10 take away 9 is positive 1, and it's equal to 0. So 2y squared plus 3y plus 1 is equal to 0. It doesn't matter that 0 is on the left hand side. Remember, think of it like this: 1 plus 1 is equal to 2, and 2 is also equal to 1 plus 1. Doesn't matter whether it's on the left or on the right hand side. Now that I've got this, can I solve it like a normal quadratic equation? Yep. I do AC, so which is the coefficient of y squared, which is 2, times the constant, which is c. 2 times 1 is 2. I'm looking for a pair of numbers that multiplies to give me 2, but adds up to give me 3, positive 3, and obviously the answer is 2 and 1. Now, because this is 2y squared, not just y squared plus 3y plus 1, I can't just put it straight into an equation. What I have to do now is rewrite out this equation here, okay? But instead of writing it down with 3y, I'm going to write 3y as a combination of 2 and 1, i.e. 2y squared stays the same. And instead of writing plus 3y, I'm going to break it down into plus 2y plus 1 plus y. Then just carry on as normal. Plus 1 is equal to 0. And I'm going to imagine I'm cutting it in the middle with an invisible line or imaginary line. I'm going to factorize each side individually. However, there's a trick to it. If I can factorize the left-hand side properly, it should be the exact same bracket on the right-hand side. So let me factorize 2y squared plus 2y. So I've realized that 2 is a common factor of both. And also 1y is a factor of both. There's no other numbers or letters that are factors of both. So what do I do to 2y to make 2y squared? I open up a bracket and I multiply by y. And 2y times something is 2y. Be careful and write down 1, please. Some people just think, oh, 2y is already there. I don't multiply by anything else. If that is the case, then essentially you're multiplying by 0, which would mean that there is no 2y here. Multiplying by 0 means 0. Now, like I said, if you've done it correctly, it should be, by default, the exact same bracket on the right-hand side. And now all you do is you fill in the blank here. What do you need here to be able to multiply with this bracket of y plus 1 to get y plus 1? And because they're both the same, it must be 1, positive 1. Now, what are my two brackets? My first bracket is what's already in a bracket, y plus 1. And my second bracket is what is outside of a bracket, so 2y plus 1. And now, because they're both equal to 0, I can say that y plus 1 is equal to 0, therefore y is equal to negative 1. So I'm solving each bracket individually. 2y plus 1 is equal to 0. 2y is equal to minus 1. Y is equal to minus a half. So I've got two y values now. Y is minus 1 and y is minus a half. What do I do with these two y values? What am I missing? I'm missing an x value. And what do I do with these two y values? I substitute it into an equation to work out what x is. Now go back to the beginning. I've already created an equation that is specifically made to work out what x is. This tells me that if I know what y is, I can do 3 take away 2 times the value of y, and that will be the same as x. So I've got a ready-made equation for x there. So all I'm going to do is substitute y into x equals to, what is it? 3 minus 2y. I'm going to do it twice. One with y equals minus 1. So x is equal to 3 bracket 2 times minus 1. And let me expand this bit first. Minus 2 times minus 1 is positive 2. Be careful, we do not do 3 take away 2. Remember BIDMAS or BODMAS. You've got a multiplication here. You've got a bracket there. So you first work that bit out first. So minus 2 times multiply the m at minus 1, which is positive 2. 3 plus 2 is equal to 5. So what that means is when x is equal to 5, y is equal to minus 1. So let me just write it nice and neat here. When x is equal to 5, y is equal to minus 1. Now I've got one more y value here, when y is equal to minus a half, again substitute into x is equal to 3 minus 2 times the x value of minus a half. So x is equal to, I have to expand this bit first, minus 2 times minus a half. So what I do is 2 times 1 is 2, so you multiply the numerators, and it's positive 2, and the denominator stays the same, so it's out of 2. So plus 2 over 2, which as we all know is 1. So x is equal to 3 plus 1, which is equal to 4. So therefore, when x is equal to, x is equal to 4, y is equal to minus a half. Now let's just double check my answer here. Let me get out the website called Desmos. And Desmos is a calculator, graphing calculator. So let's see if we can remember what these equations actually give us. So let me first write it down. X plus 2y is equal to 3. Now, without even drawing it, I know that this is a linear equation. Y is equal to 3, because I can rearrange it into the form y equals mx plus c. So as you can see here. And now the second equation is x squared plus 3xy is equal to 10. Whoops. And what does this give us? Okay, a very, very unique kind of drawing. All right, and actually, if I can find it, here, right here, there are 2 intersection points. They're very, very small. You have to zoom in quite a bit to actually see them. If you remember from our last video, what we said was a simultaneous equation can also be represented graphically. So I've drawn both graphs for you and shown that the answer to a simultaneous equation is actually the coordinates of the intersection points. So 4 and minus a half, and 5 and minus 1. 4 and minus a half, done. 5 and minus 1. So that's question number 2.